Better? Okay. So today we would not have the usual stuff you typically have, like this is the deck, this is the definitions, etc. Today, my goal was to share with you some hard-earned lessons. Hard-earned, I mean like there's the beating, there's the blood, there's being on the verge of being fired. So hopefully you would not need to make these discoveries on yourself, and it will save you a good chunk of your nerve system. And like I will be showing you, I will be telling you the concepts and the ideas, and then I will be showing you implementation in Azure DevOps. Why Azure DevOps? Well, first of all, because I love it very much, and you will see why. And hopefully, like one of my goals is to persuade you to give Azure DevOps a try. Because there is a lot of stuff out there. There is AWS, there is a whole bunch of OpenStack stuff which you can run on your machines, etc. But I still think Azure DevOps is worth trying, and I'll do my best to show you why is that so and how it can save you during your real-time, real work activities. But before we will dive into it, I would love to to rethink again, why are we talking about DevOps? Why everybody is caring, like, how do we ship our service, our software faster? This is, by the way, very nice site, storiesvisualstudio.com. They tell you, like, they present use cases about different companies and Microsoft teams who are using Azure DevOps and DevOps in general to achieve their goals. And what you see here, like, this one is the story of Microsoft Bing, which was a sad misunderstanding in some moment, and now it's gaining traction way better and way faster than, for example, even Google says. But what is interesting, you see from the idea to the release, it's 6 hours. So like basically, they got an idea in the morning, and in the evening they release it to production. Well, the first question is how it's possible, right? But I would love to ask you why it matters. Any ideas? Why business is so insistent in being able to deliver like in less than a day? Go ahead, shoot.
One thing is competitiveness, so other companies, if you're able to deliver faster than other companies, you're usually higher up.
You are absolutely right, but why is it so important?
If they release software early, they can also collect feedbacks to get a better product.
Well, that's right. You are both absolutely right, but business people, they are, kind of down to the ground. They are not that much interested in the feedback. They indeed want to collect, but not the feedback. What do they want to collect? Revenue. Right, revenue. How it happens? If you either took marketing or product development or innovation classes, you most likely saw this kind of distribution. What's the name of this thing?
Normal distribution?
Say again?
Normal distribution?
This is normal distribution, that's true, but this exact normal distribution, what does it show? There is a name, there is a common name for this thing. If you will work in software product company or any kind of product company, you will immediately see this normal distribution. So here is the thing. This is very important stuff. It's called a product adoption curve. And if you will look right here, this is the idea. For example, can we make a phone mobile? And then kind of here there is no money. Everybody says like, that's a crazy. Nobody needs a mobile phone, right? And then somebody tries it and says, hey, it's good. Show somebody. Firstly they are skeptical, then they start using it. And then eventually the wave starting. Everybody is trying mobile phone. And then kind of normal distribution, 34.5%, 34.5% are using the mobile phones. And then kind of at some moment probably it will die out, being replaced by something else. Why is it important for the business? Why do they love this curve? What does it show? How do you think? What is it right here under the curve, this colored stuff? They want to collect what? Revenue. This is revenue. There is no money here, right? But then the wave starts and the money appears. And imagine you are the company who jumps into the product curve here. So this is the money you collected before the wave died out. And the second company jumps in here. And this is revenue they have collected. This is they want to ship faster. It has nothing to do with this feedback. It has nothing to do with this, being good citizens, etc. Well, it contributes a lot. But the primary motive is collecting as much as possible of this curve. This is they want to ship it faster. Second interesting question, how do we do that? Because the reason interesting reading, if you will look into the libraries, it's typically those books are like 500 or 600 pages length, and they will tell you that the proper project goes through the 6 or 8 or 10 phases, and for each phase there is 25 documents to be prepared, and each and every document in the template phase, it means there is nothing there, it's just a template, it's around 30 pages length, and you can't proceed to the next phase until you completed all the sections in this document. It's how it used to be back in the day, but not anymore. Now we dramatically changed the way of doing things with the advent of Agile Manifesto. Have you ever heard of Agile Manifesto? Well, I don't know, how did they get through the quizzes?
It's mandatory course reading material.
Yep.
Should be nodding yes.
Yeah.
So it was in the work chapter.
Yep.
Of course.
We should add it to the quizzes.
Yes.
Even in the first class, it was discussed.
Right. So there are kind of 3 core ideas in Agile Manifesto. Working software over documentation. Second thing, people and interactions over contract negotiations. And if anybody can remember anything else? I reckon we had them in quizzes. These 4 principles. People over process. Relationship over contract negotiations. And working software over documentations are driving force behind all the Agile stuff. And in engineering, it means we employ DevOps to achieve these goals. And here is a very important notion. DevOps is reorg. It's not a new guy to hire. So if some company is trying to hire a DevOps engineer, you should be kind of very suspicious of this company. Because DevOps, it's a way of thinking. It's a way of doing stuff. If you see that they are hiring DevOps engineers, ask them why they call these people DevOps engineers. What do they do? And the right answer will be they are kind of coaches for the teams. Because you have to develop this new mindset, people have to adopt appropriate tools. So our DevOps engineers, they are kind of coaches who work with the teams and enable them to use DevOps. wrong answer will be, this is the guy who installs Maven, installs Jenkins, then builds, then writes POM files for the Maven, then you got my drift, right? So there is a job for those guys. They are called release engineers or build engineers, but it has nothing to do with DevOps. If you want to be a release engineer, that's fine, but it's not exactly a DevOps. It enables DevOps in certain areas, but it's not. What is the core of this DevOps transformation? It's actually based on these big ideas, as they call them. First one, small releases. I'm constantly seeing this problem haunting you. Then you try to write some really, more or less advanced task in your coursework. Parallelized hash table, memory mapped files. You always struggle with this stuff. Why? Because this is pretty complex task. It typically has like 10 to 20 methods inside it. And what I see, you are trying to write everything at once. And then you are trying to integrate it. And surprisingly, it doesn't work. Well, you are not alone. It happens with a lot of enterprises. So how do they suggest we approach this thing? You build first method. You build and you test it. You build second method and you test it. Then you write third method and you test it. And then you write a wrap-up method which integrates all three methods and you test it. And then kind of each of these things is a small release. And it's really easy to implement. It's a small chunk. You can rewind it in your head, analyze, figure out how it works. And all of these small things are easy to understand and easy to deploy. Second big notion, everything as a code. It's kind of hard to grasp. Imagine network. There is a router, right? There is cabling. This cabling is organized into switches. They form different channels. There is a backbone. All the end switches connect to the backbone. And sometimes we have two switches combined into the very fat backbone to deliver necessary bandwidth. It's cabling. It's devices, right? It blinks. It whispers. You shall install it into the rack. Can you imagine it turning this thing into the code? It's kind of hard to grasp, right? This is network, this is code. How do these things relate to each other? Server. You have a server. This is a box, or this is a rack. It makes noise. It blinks lights. There are hard drives there. How on earth hard drives can be code? They are, actually. So everything turns into the code. Networks, servers, firewalls, applications, databases. So you can describe, for example, the whole Bing service, which is like an enormous amount of hardware as we think of it, can be rebuilt out of definition. It means like you check out Git repo, and then you build make Bing, and then it starts creating networks, servers, databases, populate all the settings, and then like after a couple of hours, you have Bing up and running out of code, which is strange because kind of we used to configure servers in our days, right? And you have to plug in something, you have to open console, you have to type comments there, nothing like that. I will show you how it looks like in the Azure. Second thing, components. I believe everybody saw Lego, right? This is the idea how we build software. If then you need UI, you take one Lego block. Then you need on UI specific component, you take another Lego block. Then you connect it to the Lego block of APIs. Lego blocks of API talks to the Lego block of the database. And you can write a file which describes how the Lego blocks interconnects to each other, and you are getting your application. This is called component approach to building stuff. Automation. You don't do monkey business. I'm system administrator like by my primary occupation back in the day. I'm telling you that the 3/4 of what system administration is monkey business. It's typing, endless typing of commands which can be eliminated altogether. This is the idea. Let's eliminate it. Let's automated monkey do the monkey business. Zero bug mindset. Everybody hates it in the beginning. Zero bug mindset means there is no bug reports. It means like the same minute the bug was discovered, it has to be fixed. And as developers, we hate it by heart, right? But it means your software is constantly of very high quality. And actually, it's really easy to achieve. I will show you how. Resilience. Oh, that's my favorite one. I still have my mug, which my boss bought me like back in the day from the Apollo program. And it read like in the very big print on this mug. Failure is not an option. So idea was like you have to design in a way it will never fail. 20 years has passed. And I can assure you now, it's impossible. Even in the Apollo program, they had their failures. So you don't design to like avoid failure at all costs. You design to recover from failure without any problem. And because of that, there is a new discipline emerged. I believe we will have it eventually in the curricula in NIU. Chaos engineering. Chaos engineering is a discipline which intently injects failures and brings things in application to verify that application is resilient. If you ever heard of Simeon Army, then you will probably understand what is it. Simeon Army, it was invented in Netflix, and this is a set of demons which runs in the production environment and wreaks havoc, shuts down server instances, wipes out databases. And there is a kind of Kong monkey. Kong monkey shut down the whole data centers. And the applications have to deal with that. So then you're designing the software, they warn you, this is the Simeon Army. The day you will release, this stuff will start attacking your application. And you have to survive. This is a requirement. And the next big thing is a cloud deployment. So you don't deploy on the physical servers anymore. You deploy in the cloud. Why? There is a huge idea, I would say, immense idea. Cloud is programmable data center. Programmable. Why is it important? Bless you. This is the dashboard. It shows you the typical IT organization. They have 600 something requests open. How many of them are overdue? And if you think this is something like out of the way, it's a typical way it happens. 600 requests are there, 571 are overdue already. So basically, whatever you need to do by the operations team is always delayed. And they basically stalling you from doing your job. And now imagine you don't have to wait. So what you do, you open command line and you type AZ, for example, VM, create, and then you specify parameter of the virtual machine you need. 2 minutes you have it. You say, for example, I need an instance of cognitive services. Easy cognitive services, create instance, which service you need, how much you need. 2 minutes, you got it. No waiting, no persuading anybody that you need this service. As long as you can afford it, you have it in minutes. This is the big idea. And there is even bigger idea behind that. When I was young, I was running my custom Linux distro built by me, which had a custom built kernel in it, built by me, which was running on the workstation built and configured by me. And I was writing the code there, not using any components whatsoever, because I don't trust anybody. I can do it better than anybody, believe me. And I was using my customly modified Emacs. This is my custom shortcuts defined in it and macros written for it. And I was immensely proud of that. 20 years from this moment, I'm kind of tired of that. Because if you think in the terms of effort, so think about it. You have to build workstation, custom workstation. Think through all the components and then spend a couple of hours putting this stuff together. And then you have to spend a couple of hours building your custom kernel. And then you need a couple of days to build your custom distro. And then you need a couple more weeks customizing your own Emacs. And then, you know what? Kernel version 2.0 becomes obsolete. And there is kernel version 2.1 out there. What have you do?
Rebuild.
Rebuild everything. You have to, because you have to spend, now you have to spend enormous time maintaining it. And I'm tired of it. I have more interesting things to do, more interesting tasks to accomplish. In the cloud, you don't care about it. You just tell, give me the latest Ubuntu server. Give me virtual machine that's the latest Ubuntu server. And you are getting it. Please, this is a video file. I need transcript out of it. Give it to me. 10 seconds after that, you are getting transcript of the file. You don't need to do anything. Well, you need to feed it into the service, but then you are getting stuff back. And you don't need to do anything. And it saves you an enormous amount of time. If you are a tiny company, like a couple of guys, building something really new, back in the day, you was not able to build anything because you have to buy servers, you have to buy software on it, you have to install it, you have to configure it, then you have to buy to write all the components which do what you need, and then by the time you are ready, the wave has died out, and you're not collecting any revenue. Now you can spawn your infrastructure in minutes, you can buy components you need. If you can't afford buying it or don't want buying it, you can use open source components. And you can, and there is like one model which really matters. And you are focusing your effort on building this thing. And you can compete with the guys who who are multi-million companies. Why? Because you share the same infrastructure. You can have access to the same level of services they have. And if you think over it, it's a very big idea. You don't have to do plumbing work anymore.
One way of thinking about it is if you were starting a pizza delivery company in the old days, you would start by building a road and then designing a car. Now you have a pizza delivery company, you use the existing stuff.
Right. So you don't have to build it. It's out there. And the cloud companies, they provide you services which you can use. And the extremely nice thing about the Azure and about Microsoft ecosystem is that it has all three components. available or made available for you to do this stuff. First one is Azure, which is programmable data center. You can program it through the SDKs. So like you can spawn instances, or you can shut down or order services right from your code. This is what we tell like everything as a code. You can create database, populate it with data, run calculations, remove database, and clean the data right from your code. It's accomplished by the Azure. And there is another thing which is formerly was called as Visual Studio Team System. It's a set of services which enable you to continuously deliver your software and your services to the Azure. We will look into what does it mean and how it works. And there is a third component which you don't value much until you lose it. This is Visual Studio EDE, which is integrated with this stuff and this stuff seamlessly. It means like you can order services, manage services, create, modify, shut down, whatever you need, all from your EDE, which is extremely convenient. So you don't need like having 2 large monitors and 20 CLI windows in which you are typing commands to bring stuff together. You have one EDE window, and from this EDE window you can do whatever you need. And I'm going to show you the simple example of the application. Actually, I prepared a sophisticated example for you, but I can show it because of the security restrictions configured like in NAU environment, which is probably right. So I will be showing you the really simple application following the classic MVC pattern. One of the big enablers of this component style and like easy to customize architecture was advent of MVC pattern. Have you ever heard of it? You will. So no matter which technology you would be using, you will be writing in Python, you will be writing in Java, you will be writing in .NET, doesn't matter, you will face it. Any enterprise application nowadays follow this pattern. There is kind of some deviations out of it, but the core is always the same. 3 components: view, controller, and model. This thing represents objects. If you think about any application operates entities, accounts, invoices, quotes, purchases, transactions, etc. This is models. So you have a code representing these models. And you have a code which stores them. There is a view. View, it's typically then you are trying to log into application. Then you are interacting with this view. But this view need to somehow to retrieve the model of you from this part of the application and verify that your password actually matches. Controller does this thing. So you go to the view, you say kind of, I'm Dennis, I want to log in, submit. Then controller is called, and the view says, hey, this guy is just submitted this information and claims he is Dennis and his password is password. Is that right? It says like, wait a minute, talks to the model, retrieves the information, and says, yes, this is Dennis, and his password is indeed password. Tell him he's not right. And then kind of display him his default view, and his default view is homepage.
I think it's worth pointing out, since some of them are working in Django, that Django is an implementation of the MVC pattern.
Yep. So you recognize it. They have slightly different conventions. Views is called what it reminds you in Django. Views. Templates, right. Controllers. Say that again? They call it view, but if you will look into what's happening inside, it's a logic, so it's a controller. And then, how do they call it?
That one's model.
This is model, guys.
Models.py.
Yep. Models.py. This is models.
Views.py
Yep.
is the controller, and the HTML pages.
Yep. So then you will be working, you always will be working this traditional 3 or 4 layer architectures. There is a presentation layer, probably there is a service layer, it may be but may not be. Then there is a logic layer, controllers, and then there is a data, which is models. What do you think, what is this service layer? Those of you who use Angular, those of you who use React, you very often interacting. This is a service layer. Then you call the REST API, you're interacting with the service layer. And it doesn't matter what you will be using. You will be using .NET Core, you will be using Django, you will be using Flask, you will be using Spring. You will always encounter this pattern. So you have to learn it by heart. It will save you an enormous amount of effort. And in fact, Microsoft platform has his very own implementation of this 3 or 4 layer architecture, which is surprisingly called MVC. And there are 2 versions of MVC, MVC and MVC Core. And MVC Core is pretty much like Java. It runs everywhere. You can run it on Windows, on Linux, on Raspberry Pi, whatever you want. You can edit it in Linux, you can edit it in macOS. So it's truly cross-platform. And it integrates natively this Azure. So if we will look into the where is it? If we will look into the Microsoft ecosystem, we will see that like most of ecosystems, they cover part of it. For example, Azure, for example, AWS, they cover this part really good. But this part is missing. It's left like on your shoulders. Java, on the contrary, they have this part really well built. But this part is, again, they're wetting it on your shoulders. Microsoft ecosystem, they have everything covered. You build the code, you build the code in your IDE, you build it there. You can auto-test there. You release it, you have daemons to deploy it. It will run in Azure. You have a bunch of services to monitor it, and then you can like start again over this thing. So let's try to follow this infinity sign on the Microsoft platform. So this is the IDE which is connected to the Visual Studio Online service. And you see that there is no internet here. It will be fine if there is no internet here. Okay, let's try to localize it. So this is Visual Studio Team System, or Azure DevOps, as we call it now. And right from here, you can connect your Visual Studio to the, it's basically pretty much like the Jira, which we are using for the project. But also it has a very nice thing here. If you will go to the repos and click clone, you will connect your project right to the Visual Studio. And from there, you can do pretty much like whatever you need in project management you want to do. You will see all the changes you did to the code base. You can manage branches. You can do pull requests. You can synchronize your work with your colleagues. You can track work items like what you have to do. You can start builds and manage all the settings from there. I'm actually surprised that I don't have a connection from here, but anyway, I have project open here just for this particular case, so I can show you what's going on here.
What's the problem you're hitting with the connection?
For some reason, my virtual machine does not connect to the Wi-Fi network.
Oh.
So let's see how this pattern looks like MVC, how it's implemented here. Surprisingly, in every .NET Core project, you see the models. And if you will look into the model, like say kind of news article, you will see that this is actually a class. Just a class which has a number of properties defined. And then the database structure for this thing is generated for you. There is a special setting right here in the application DB context class, which is wrapped around this thing. It says kind of, please show all the news articles, all the topics, or the files for anybody who is using application, and then the application starts. If these entities are missing on the database or they changed from the previous one, please update them. This is it. You don't need to write SQL. You don't need to define properties in SQL. You don't need to see SQL whatsoever if you don't want. You just add properties to the class, and then you rebuild the application, and then these fields appear in your database. Code first. So you write the code, and then everything is done for you. Second thing, controllers. This is logic, which we were talking about. This is the not nicest implementation whatsoever, but you can see here interesting things. For example, to get the news articles from the database, you remember from application security, from privacy classes, which we had, these frightening stories about SQL injection, about properly parameterizing all the queries, etc. You don't have to deal with it, at least in .NET world. This is what you need to do if you want to retrieve news article. From this DB, which we defined the retrieve news articles, please also include topics and pictures to them and give me the list. No SQL injections, no wrong queries. You are operating plain vanilla objects. And you can take as much as you need from there, and you can ship them back to be displayed on views. What is view? Well, it's kind of pretty much like template in Django. For example, let's open this one. It's pretty much like template in Django, and it works very same way. You include something into it. There is more interesting one here. Just want to find something which has some lengthy code embedded in it, but I don't see anything. So basically, it's pretty much like template in Django, and it does pretty much the same things. And the nice thing about it that pretty much like any modern language, you can inject JavaScript into it, or you can just ship data to the view and then render it completely using Angular or Vue or React or whatever you need. So it's customizable to the unimaginable degree. Sometimes it's bad because kind of somebody is calling for help and you look what they have done there, and you see like there is a parts of Angular, Vue, jQuery, and going back and forth between controllers, and so it's not always good to have that degree of customization. Okay, so, and there is one very important thing which we will see in the project, except the code which I shown you. There is, on the very top level, right to the sample web application, there is a project which is called sample web application tests, which is containing, as you can imagine, tests. Very quick survey. How many of you guys by heart believe that the tests are important and every developer should write tests for his own code? Well, a lot of you. But to be honest, did you do it like you believe? Right, so everybody knows this is right, but then kind of it's extra time, right? You have, and sometimes it's pretty dumb work. You just written the class has 10 methods, and like 5 properties, and you have to write tests covering this stuff, so you need like, for every method you probably need at least a couple of tests, you have to write skeletons for it. This is exactly plumbing work which we hate, right? In Visual Studio it's not like that. You point to the class, you point to the method, and then kind of there is a menu here, and you just create tests for this thing. And from your code, everything will be generated for you. It will generate failing tests, and you just need to write actual tests which you need to fill out. And then you can run them as a separate project, and they will be the part of the continuous integration project. A lot of people actually don't believe that the tests are that important. So let me tell you the story. This is not my slides. I believe that someone from Microsoft was presenting that on the TechNet. But still, I will tell you the story of the Knight Capital. Financial company working, as far as I can remember, on NICE. And then they just released the new feature, replaced some code. It was touched last time 9 years ago. And the guy who was doing deployment just forgot to check like one flag on this code to enable it. And then these things start generating like close to $200 orders every minute. Guess how long it took them to shut the application down, to figure out what's going on, to detect what's going on, to react and to shut the application down. So basically every minute it's 200,000. So try to estimate how much it costed them. You are really close. They had to file for bankruptcy after that. And the fun thing is that they didn't even realize for some time what's happening. So this is why testing and monitoring is important. But again, everybody kinds of knows this, right? That it's extremely important to have proper documentation. It's extremely important to test it. But then, this is proper documentation, right? So, And it's not the end of it, right? So it's basically normal flow and just some alternative flows. And there is kind of another page of different deviations which may happen. And somebody has to write it, and you have to read it. And then you have to implement it. And then another guys, they will take Excel. And for every step of this document, they will write a thing like that. Go there, enter that, click that. You expect to see this thing. Then you kind of go there, click that, enter that, and then you see this thing. And then what do you think? They open this Excel, they go there, they enter data, click, and mark if it's passed or if it's failed. Let's say we have a small application like 20 use cases, right? And we have very capable testers who do it like that. And we just have a new release, and they have to run this test for 20 new requirements. How long it will take? They will need 6 hours just to run tests manually. So we are not talking about releasing every 6 hours. We are talking about testing for 6 hours. And there is one important thing here. Look here, failed. See bug. They have to submit bug. The bug goes to developer. Developer has to read it. Developer has to find where it's happening. Developer has to fix it. Developer has to submit bug fix. Then he has to notify tester. Tester has to pull the build which where the bug was fixed. Then he has to run the test again and verify that it's not there. It's called regression. And this is the amount of the regression for the typical software project. So this is a primary work, and this is the amount of regression. Can we talk about releasing every 6 hours if we have this amount of regression? No way. So it's more month than hours if we have this amount of regression. So what do we do? If we will look into this Excel, this is a really dumb thing, right? We basically need to enter something, click something, enter something, click something, expect something. So what the idea is coming to our mind? Let's automate it. Why do we need like 20 guys doing all this monkey job and giving us this enormous wait time? Let's automate it. And this is exactly what we do. We write automated tests. And another big idea, we combine these tests, these requirements. So if you will look into the test project, you will see this amazing thing. For example, this is the typical requirement as we defined it. This is a requirement about adding new article. Given I'm registered user, I log in, and I provided a headline, and I have provided this and that, and then I click save, then I should be redirected to the new page, and I should see, reminds you something, right? This is structured requirements language called Gherkin, and it's kind of, you can avoid writing this long Word document. You can just write this scenario like that. And then you can use it to actually generate the code. And code behind these things, if you will look into it, it's kind of some samples. This is exactly what we were talking about. To implement this step, you have to get new driver, then you initialize this driver, then you go to URL, then you retrieve something, and then you check that this and that is something. And you can even, as you go, you can even collect screenshot and save them in the test reports. So you eliminating manual testing altogether. So it's a robot runs the stuff. If something is broken, it will take a screenshot and let you know immediately that something is broken. And we make an agreement. Then each and every time we are implementing a requirement, we add a test to it. And then kind of we launch this thing and we collect information and we see what's happening. And if something is broken, I broke this thing intently. Straight from your IDE, you see that the thing is broken. Changes you just did broke the application. You don't need to build it, deploy it, tester don't need run to test cases, find the thing, submit the bug, send it to you, you have to read, blah, 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 blah. You see it straight away from your method. You just broke it.
How did we move from the requirements to the test code? How was that done?
Pretty much the same way we were generating test cases. You point to the scenario. It's already generated. So basically, you just point there, and if there is no test behind it, it will tell like there is no test for this thing. Generate, it will generate. Okay, and then you did your changes and you are ready to submit your code. What will happen next? Continuous integration service will fire up. Let's make a short break, like 10 minutes, and after that I will show you continuous integration and continuous deployment in Azure. So far, kind of you were working inside your confines of the Visual Studio. And then you do the changes. Let me change something.